In this problem, we look at an application involving direct and inverse variation. The resistance in ohms of a circular conductor varies directly with the length of the conductor and inversely with the square of the radius of the conductor. If 50 feet of wire with a radius of 6 times 10 to the negative third inch has a resistance of 10 ohms, what would be the resistance of 100 feet of the same wire if the radius is increased to 7 times 10 to the negative third inch? I'm going to start by defining some quantities. We're going to let R, or capital R, equal the resistance. We're going to let capital L equal the length. And we're going to let little r equal the radius. Because the resistance varies directly with the length L and inversely with the square of the radius, we can write capital R is equal to K times capital L over little r squared, where K is our constant of proportionality. To find the value of K, we'll use our given values for R, L, capital R, L, and little r, and plug them into our equation and solve for K. The initial values that we received were that the resistance was 10 ohms, so 10 equals K times the original length would be 50 feet, so capital L is 50, and the radius was 6 times 10 to the negative third, 6 times 10 to the negative third, and that's squared. This will give us 10 is equal to 50K divided by 3.6 times 10 to the negative fifth power. If we multiply both sides by 3.6 times 10 to the negative fifth, we'll have 3.6 times 10 to the negative fourth is equal to 50K. Divide both sides by 50, and we get 7.2 times 10 to the negative sixth is equal to K. Now we can use this value for K to answer the question that's actually asked, and that is, what would the resistance be if we had 100 feet of the same wire, but we increased the radius to 7 times 10 to the negative third inch? So we get R is equal to 7.2 times 10 to the negative sixth. That was our value for K. L is 100, and the radius 7 times 10 to the negative third, and that's squared. This will give us 7.2 times 10 to the negative fourth divided by 4.9 times 10 to the negative fifth. If we work this out, we'll get that R is approximately 14.69 ohms. So the resistance, if we had 100 feet of the same wire but increased the radius to 7 times 10 to the negative third inch, would be roughly 14.69 ohms.